but if we solve for acceleration and we get negative, that means it's wrong because we are supposed to put the negative sign, or is it?
Yeah, this is because we chose the direction of acceleration for the 7 kilogram mass to the right, which is the direction of that acceleration, so that's positive A.
Okay.
This one, because acceleration would be down with the same magnitude,
Yeah.
but up is positive, so it's gotta be negative A here. If you left this as just plain old A, then you're gonna have a conflict. I'm not quite sure how it's gonna end up, but if this were positive, if you drop that negative there, I would expect this A to be a negative number and that A to be a positive number, which is a conflict. And I don't know what the final result's gonna be.
Okay.
It's just simpler if we had chosen down to be positive, but.
Sorry. Hey, I looked at all you guys and y'all all were like,
I mean, those are-
"No."
At least we know next time.
Yeah.
All right. What comes after the equations of motion?
Substitution.
Substitutions.
All right, for what do we have an independent equation?
Friction and weight.
So I have ft cosine theta t minus UKY7 equals M7A. Y7 equals W7 minus FT sine theta t. And FT equals the FT minus M4G equals negative M4A.
Dr. Fox, quick question.
Oh, I forgot to make that
So
substitution.
since that our rope is ideal, does that mean the acceleration for the 7 kilogram and the 4 kilogram would be the same?
The magnitude of the accelerations are the same.
Okay.
So we've got the friction and weights, all right. Now let's just make sure that we have enough equations, that there's not some issue here. I know theta t, we calculated that to be 19.158 degrees. I know mu k, I know m7, I know theta t, I know g, and I know that, I know that, I know that, I know that. So my unknowns are acceleration, the normal force, tension. 3 unknowns, 3 equations. This is mathematically solved. So how do you solve it?
Substitute.
Pardon?
Substitute.
So we can get rid of the y by substituting that in for y right there. So I have ft cosine theta t minus uk times m7 g minus ft sine theta t equals m7a. Actually, I could solve for ft and plug in that one. Let's go ahead and do that. So I'm gonna take this, well, bring this over, substitute that in for ft. Oh, easier than I was thinking. So we're left with negative m4a minus plus m4g times the cosine of theta t. So at this point, oh, I've got another tension there to substitute in. All right, I'm gonna restart that. So we had ft cosine theta t minus mu k y7 equals m7a. Then I've got y7 plus ft sine theta t minus W7 equals 0. And then I've got FT minus W4. Minus M4G equals negative. There. M7G equals negative M4A. Those should have been the equations that were in yellow over here. Is there a mistake? All right, so from this equation, we can solve for the tension. So the tension is equal to negative, is actually M4G minus M4A. I know G, little g, is going to be bigger than the acceleration because it's not going to accelerate faster than it would just under the force due to gravity. So that's going to be a positive number. That's encouraging. From this equation here, I know that y is equal to M7G minus Ft sine theta t. And so I can plug this in for there, and this into here, and my tension into there. So I end up with M4G minus M4A times cosine of theta t minus UK times my normal force, which is M7G minus my tension, M4G minus M4A times sine theta t equals M7A. Now let's plug and chug. Because I think we know everything.
No, we don't know acceleration.
Except for acceleration, which is what we're trying to find. You're correct. We know everything except acceleration. So 4 times 10 minus 4. Oh, I have acceleration over here. It's not straight up plug and chug.
That's why I said
Acceleration.
Thank you, sorry.
It's okay. I was
So-
like, I think I have written on my paper, but.
M4G cosine theta t minus M4A cosine theta t minus mu k M7G plus mu k M4G minus mu k M4A. But that is sine theta there. So that will be sine theta t equals M7A. So the terms I have with A in it, I've got this term, and this term, and that term.
Can I ask you something?
Yes,
This is a question like this is gonna be on the test?
say it again.
A question like this is gonna be on the test?
It's fair game,
So yes.
especially since we've gone over it.
Oh, crap, sorry.
I just gotta move the rope, it's like back there.
All right, so we have M4G cosine theta t. We know all that stuff.
Let me take all that.
Minus UK M7G, we know all of that, plus UK M4G sine theta t equals, and then all the rest of the terms have acceleration in it. So I got an M7, and then I've got a plus UK M4 sine theta t plus M4A cosine theta t.
Let me just plug it in.
Figure out the left-hand side, figure out what's in parentheses, divide, and the world is just a little bit better place.
That's supposed to be M4 cosine theta t, right? Not M4A for the last part?
Oh, that. They did it from over there. Yeah, that A should not be there. All right, now when I got a long string of letters like this, a quick check is just to make sure units work out. Because remember, sine of theta and use of k are unitless. So this is a unit of mass, unit of mass, unit of mass. Over here, I have mass times acceleration. Mass times acceleration, mass times acceleration. So on the left-hand side, I have what will be newtons. On the right-hand side, in parentheses, I have kilograms. I divide, well, I'll get meters per second squared in the end. And the answer is,
Can you take mass out of everything? Is that an option?
no, because I have two different masses. However, if we conveniently just said masses were the same, you would, I think that's what I read on the test, oversimplified.
I got 1.82.
1.82?
Yeah, did you get the same one?
Yeah, I got 1.82.
Is it like 1.8177? Yeah. It's just one, you just round it to the nearest hundreds.
That's fine, that's not the
Yeah.
dramatic pause here.
Oh, meter per second. So the main idea is just think of the rope as like a vector to solve for the tension in there.
Yeah,
Okay. Is that why you tried avoiding like to draw the pulley?
good, say that
Is
again.
that why you tried avoiding is that the reason why you avoided drawing the pulley?
Yeah, I didn't want to then get into what's the height of the pulley, which angle is the pulley going on, so that's why and it's ideal, so,
Doesn't really matter.
yeah, scraping over the ground, scraping over the pulley, same thing. That was a fun little problem.
We enjoyed it.
I'm glad.
It made sense.
I think you just should put it on this test because we did so well on this one.
Noted.
Okay, keep that in mind.
Other questions? I guess questions on this?
Is it the same one?
Basically, I got 1.85.
8.5?
Probably did it for the season.
Probably.
It's quite possible I would not notice if you had 1.85 versus 1.82.
Doesn't really matter.
What would it? Same thing.
It's one word is rare.
Other questions? Kritika?
Just a question about the lab that I didn't do tomorrow, like yesterday. Would I have to do it again, or can I get the numbers
Which one was it?
The Atwood machine, the one we had to drop like away.
Send me, if you sent me an email asking for it, the data. Send me an email asking. Other questions?
The lab that was like, we did last Wednesday, that'll be due Thursday.
I thought it was Monday.
It's still on
Tomorrow's the test day though.
Yeah.
Yeah,
so
it's not,
Monday.
it's not due the day of the test,
Right.
it's due the next lab, which is
Okay.
Monday.
Never mind, my bad.
If you have it ready on Thursday, feel free to submit it.
I'll return in the master set, the one that's extra credit on Thursday.
Okay.
That's my thing.
So, if we know Newton's gravitational laws, do we have to memorize what's his name again? Kepler's laws?
No.
Okay.
Yeah.
It's just that
Kepler gets more press than I think he
Yeah.
deserves.
like it's that one whole equation that we did is enough to suffice for the whole Kepler's law, right?
Say it again?
The one equation that we talked about with Newton is enough to like cover the whole Kepler's law.
Yeah, I mean, the other ones, if you're really interested in Kepler's laws and the connection with Newtonian mechanics, I have the series of 8 videos where I do it bit by bit.
Okay.
One of those videos is the second most popular video I've created.
How many views does it have?
My most popular one is 11,000 views. I think this one has 5,000.
Nice.
It's up a couple thousand.
Thanks.
It's the conversion from rectangular to polar, or polar to rectangular coordinates.
That's cool.
Or elliptical. It's anyway. And a third of the people are still watching at the end. You about to ask a question, Lauren? No, so it's not condemning.
Actually, I have a question.
Yes.
So, let's say a car has a rope attached to it and it's moving in a circular motion. So the tension would be the one pointing to the center, and friction is moving away. Is that correct?
Well, then,
So car's going in a circle.
And then there's a rope attached to it to keep it moving in a circle.
Oh, okay, okay.
So,
I was picturing
would-
something different.
Would
Alright.
tension be in the center and then friction would be pointing away? Or would they both be pointing the same direction?
Alright, so in the case of a car going around a curve, let's say it's in a flat road, we got 2 different frictions involved here. There's a friction that's pointing forward, which is presumably static friction. And then there's gonna be another set of friction that's, which may be pointing inwards or outwards depending upon how fast the car's going. Because it requires a certain amount of force in order to keep the car traveling in that circle. If you're driving above a certain amount, then the tension, you'd have, the car wants to
Move away.
move away, so friction would be acting inwards.
Okay.
No, friction's gonna act inwards either way. So there'd be the friction that we care about, that would be acting towards the center, so there'd be tension and friction both acting inwards.
Okay.
So if you're driving below the speed limit, the tension would actually be 0. If you're driving over whatever maximum speed you need to do, or whatever the maximum speed is,
Then
then
tension.
the tension would start to kick in to make up for what friction did not.
We wouldn't have that type of question in test, right?
It's fair game. I have not written the test. I do not write the test too far in advance because of this reason.
what reason?
Because students ask me, you know, is this on it? And I'm not going with, well, I know it's not on it, so, you know, but it's fair game.
You don't know what's gonna be on it. Do you make it you're gonna make it tonight?
Yes.
Yes?
Okay. Great.
You want me to make it tomorrow morning?
Whatever he feels like.
We can do it on Friday.
I've got, I think a 10-minute gap between classes tomorrow, I can. That's the, quickly, let me print out a test from a previous year. Oops, I forgot to change the date, oh well.
We wouldn't notice.
Everywhere.
Were there any equations, that we are expected to have memorized? I remember you mentioning something about one of them. Is there
The next test,
Test, okay. So everything else, like the FC equals MAC equals all of that?
that'll be on it.
And then these ones, okay, that'll all be on it.
How about the equation for time, frequency, and period? Would that be in the test as well, or do we have to know that one? Do we have to know?
I mean, period, you should know what the period is, I don't think I have a formula for it, it's the time it takes for repetitive motion to happen once.
Okay.
Yeah, it's just vocab at this point.
Mhm.
Later on, we'll get more sophisticated use of period, frequency, and so forth.
Since we're taking the time to ask questions, is the master set, is everyone submitting it today?
No.
Okay. So for the 7, could you, I don't know if I can ask this now or if you want me to ask later, could you explain B, like what, I really don't understand.
All right. Force diagram is the first thing you do.
Mm-hmm.
If the force diagram gets messed up, then the rest of the problem becomes either incredibly simple or overly simple or impossible. The essence of the problem. Mass 2, 1, 3, and 4.